Birthdays and permutations. Suppose a group of 5 people is in a room. Find the probability that at least 2 of the people have the same birthday. In symbols, what's the probability of at least 2 people having the same birthday? To work this problem out, we're going to work it out in 3 steps. Here's the first step. In how many ways can 5 people have a birthday such that no 2 people have the same birthday? Almost seems like the opposite of what we're looking for. In how many ways can 5 people have a birthday such that no 2 people have the same birthday? That is, they all have a different birthday. So here are the 5 people. The first one has 365 days to choose their birthday. The second person, 364 days to choose their birthday. The third person, 363 ways to choose their birthday. So after the first person, each of them has 1 less day to choose their birthday. So notice how it's decreasing by 1. This is a multiplication principle with no repetition, since they can't choose the same birthday. Another way of writing the multiplication principle with no repetition is to write it as a permutation. So this can be represented by a permutation of 365, taking 5 at a time. You could do it either way. This one lends itself for quick calculator use. The second part, to answer the question, we would need to know in how many ways can 5 people have a birthday. Notice there are no restrictions here. Each person has the 365 days to have their birthday. Multiply it out. This is a multiplication principle. But since they're all the same and these are being multiplied, you could write all of this as 365 to the 5th power. So we did the counting. Now let's bring in the probabilities. The probability of not having the same birthday. So remember, in a probability, you have a numerator and a denominator. What's in the description of the probability you're looking for, that's going to be answered by the numerator. So remember, this was the count. In how many ways can 5 people have their birthdays such that none of them have the same birthday? Probability of not having the same birthday, you write this number down, you write this number down. Remember, the bottom number, the denominator number of a probability, is always a total. For our problem, this represents the total number of ways people can have a birthday. 5 people can have a birthday. So the third part of the problem, observation. Notice this is a universe, this is a sample space. It always carries a probability of 1, which is 100%. And what we've been working with is this portion, probability of not having the same birthday. And this is what we had just a little while ago. So you could get to the probability of having 2 people, at least 2 people have the same birthday by finding this one out. So all you have to do now is just say 1 minus this part. So 1 minus this part, and it'll give you the probability of at least 2 people having the same birthday in a group of 5 people. So the probability of at least 2 people having the same birthday amongst a group of 5 people would be what you get from here, which is 0.027. If you turn it into a percentage, this would be 2.7% chance that at least 2 people will have the same birthday in a group of 5 people. The chances are pretty low.